In this session, we'll continue with progressions and we'll take a few problems on arithmetic progression. Now here the first one is the sum of all two-digit numbers. The two-digit number means the numbers are starting from 10 until 99. So the sum of all two-digit numbers which when divided by 4 yield unity as remainder is the given options. So it means if we take all two-digit numbers which when divided by 4 give remainder 1, and if we add all those numbers, then what will be the sum? Now the two-digit numbers, it starts from 10 and it's up to 99, and if we select only those numbers which when divided by 4 leaves a remainder 1, then those numbers will be 13, 17, 21 and so on up to 97. Now here we see that this is in arithmetic progression. 13, 17, because 17 minus 13 is 4, and 21 minus 17 is 4 and so on. So therefore A is equal to 13, D is equal to 4 and the last term Tn is equal to 97. Now to find the value of n, we can use the expression like Tn is equal to A plus n minus 1 into D. Now substituting the values, Tn is 97, A is 13 and D is 4 multiplied by n minus 1. And solving it, we get n is equal to 22. So it means there will be 22 terms in this series or in the sequence, that is 13, 17, 21 and this 97 will be the 22nd term. Now we want to find the sum of all these numbers, so therefore we can use the summation formula, that is Sn is equal to n by 2 into 2a plus n minus 1 into d. Substituting the respective values, n is 22 by 2 multiplied by 2 and a is 13 plus 22 minus 1 into 4, and solving it we get 1210. So therefore the correct answer is 1210, which is the sum of the two-digit numbers which are divisible by which when divided by 4 will give the remainder 1. Now the next is, if log 2 base 5, log 2x minus 3 base 5 and log 17 by 2, 2 raised power x minus 1 base 5 are in AP, then the value of x is 0, minus 1, 3 or none of these. In this case the answer is 3, that is C. Now let's see how to arrive at the answer. Now here we have log base 5 2 log base 5 2x minus 3 and this term in AP. So therefore log base 5 2 x minus 3 minus log base 5 2 will be equal to log 17 by 2 2x minus 1 minus log 2x minus 3. So that's what written over here, log base 5 2x minus 3 minus log base 5 2 will be equal to log base 5 17 by 2 plus 2x minus 1 minus log base 5 2x minus 3. Now whenever we have log a minus log b, whatever the base, it always be equal to log a by b. So therefore this becomes log base 5 2 raised power x minus 3 divided by 2, and this will be equal to log base 5 17 by 2 plus 2 raised power x minus 1 and this divided by 2x minus 3. Now we'll substitute 2 raised power x is equal to y. So therefore this becomes log base 5 2 raised power x is y, so y minus 3 divided by 2. Now this will be log base 5 17 by 2 plus 2 raised to the power x minus 1 can be written as 2 raised to the power x divided by 2. So it will be y divided by 2 and 2 raised power x will be y minus 3. Now this log base 5 and log base 5 both sides are there, so we can cancel it out. So finally we get y minus 3 by 2 is equal to 17 by 2 plus y by 2 divided by y minus 3. Now if we solve it, this 2 will come over this becomes 1 by 2 into 17 plus y, and this 1 by 2 cancels, so 1 y minus 3 multiplied with y minus 3 will be equal to 17 plus y. So y minus 3 into y minus 3, and this is equal to 17 plus y. If we solve, we get y square minus 7y minus 8 is equal to 0. Now this is a quadratic equation. Solving this quadratic equation, we get two values of y. The first one is y is equal to 8, and the second one is y is equal to minus 1. Now we started with 2 raised power x is equal to y, so therefore it means 2 raised power x is equal to 8, or 2 raised power x is equal to minus 1. But 2 raised to the power x can never be minus 1, so therefore 2 raised to the power x is equal to 8. 2 raised power x is equal 2 raised power 3 is equal to 8, so therefore we get x is equal to 3. So therefore the solution is x is equal to 3. Now the next one is if S1, S2 and S3 are the sum of N1, N2 and N3 terms respectively of an AP arithmetic progression, then we want to find the value of S1 by N1, N2 minus N3 plus S2 by N2, N3 minus N1 plus S3 by N3 into N1 minus N2. Now we have to check which of the following options is correct. Here the correct option is 0, that is A. Now let's take the problem. We know that S1, that is Sn, is equal to n by 2 into 2a plus n minus 1 into d. So therefore S1 by n1 will be equal to 1 over 2, 2a plus n1 minus 1 into d. Similarly, we'll get S2 by N2 will be equal to 1 by 2, 2a plus N2 minus 1 into d. Now, the expression over here that we have is S1 by N1 into N2 minus N1 plus S2 by N2 into N3 minus N1 plus S3 by N3 into N1 minus N2. So, we'll substitute the respective values over here. So, this will be equal to S1 by N1 is 1 by 2 2a plus n1 minus 1 into d. So 1 by 2 into 2a plus n1 minus 1 into d, and this n2 minus n3 will come. Similarly here S2 by n2 will be 1 by 2 2a into n2 minus 1 into d, and n3 minus n1 will come over here. And similarly the next one will be n1 minus n2 divided by 2 and this. Now solving this, we can take 1 by 2 common from here. If we take 1 by 2 common from here, the first one, 1 by 2, if we take common here, we get 2a plus n1 into d minus d. So here 2a n2 and minus 2a n3 plus solving the first expression, similarly solving the second expression, solving the third expression. Now all these terms will get cancelled out. This 2a and 2 is there, similarly 2a and 2 is there, and similarly 2a and 1 is there, and 2a and 1. So all these terms will cancel out, and finally we get the solution as 0. So therefore the correct answer is A. Now the next problem is if Sn denotes the sum of n terms of an AP, then we want to find the value of Sn plus 3. Sn plus 3 means the sum of the AP up to n plus 3 terms. Minus 3 Sn plus 2 plus 3 Sn plus 1 minus Sn is equal to what? So here the correct answer is 0, that is A. So we have the expression for Sn is equal to n by 2 into 2a plus n minus 1 into d. Now we want to find the expression Sn plus 3. So Sn plus 3 will be n plus 3 by 2 into 2a plus, in place of n we'll write n plus 3 minus 1 into d. Similarly the next term is minus 3 into Sn plus 2. So minus 3 into n plus 2 divided by 2 into 2a plus n plus 2 minus 1 into d. The third term is 3 times Sn plus 1. So 3 times Sn plus 1 means n plus 1 by 2 into 2a plus n plus 1 minus 1 into d. And similarly the last term is Sn Sn will be n by 2 into 2a plus n minus 1 into d. Now from the first one, n plus 3 by 2, 2a plus 3 minus 1 is 2. So n plus 2 into d minus 3 n plus 2 divided by 2. 2a plus n plus 1 will come from here. And then the next one is plus 3 n plus 1 by 2. 2a n plus d, 2a plus nd, and 2 n by 2 into 2a plus n minus 1d. Now if we add all these terms together, so first we are taking a common. So if we take a common from here, we get an. From here we get a into n plus 3. From here we get a 3 into 3 into n plus 2. And then taking all together we get n, 3 minus 3n minus 6 plus 3n plus 3 minus n. Similarly, we can take d by 2 also common. If we take d by 2 common from the first one, if we take d by 2 common from the first one, we are left with n plus 3 into n plus 2. Similarly, d by 2 is taken from the second one, we are left with minus 3 into n plus 2 into n plus 1. So similarly, if we solve, we get d by 2 into n square plus 5n plus 3 and minus plus 6 into minus and all these terms. And if we solve it, this n and minus 3n and plus 3n is 0, n and minus n is 0, 3 and plus 3 is 6, minus 6 is 0. Similarly, this term also will get 0, so a multiplied with 0 plus d by 2 multiplied with 0 is equal to 0. That will be the correct solution. Now the next problem over here is the sum of first 4 terms of an AP is 56 and the sum of the last 4 terms is 112. If the first term is 11, then the problem is to find the number of terms in an AP, whether it is 10, 11, 12 or 13. So here the correct answer is B, that is 11. Now let's see how we arrived at the solution. Now let's consider the AP as A, the first term, the second term is A plus D, A plus 2D and so on. Where A is the first term, D is the common difference. Now according to the problem given over here, the sum of the first 4 terms is 56. So therefore T1 plus T2 plus T3 plus T4 is equal to 56. Now T1 is the first term, so it is A. T2 is the second term, A plus D, A plus 2D, A plus 3D is 56. So therefore, simplifying this equation, we get 4A plus 6D is equal to 56. Now in the problem, it is given that the first term of the AP is 11. So substituting A is equal to 11. So 4 into 11 plus 6D is equal to 56, and solving it, we get D is equal to 12. Now the second thing given in the problem is the sum of the last 4 terms. The last term is Tn, the second last term will be Tn minus 1, then Tn minus 2, then Tn minus 3. So this all sum is equal to 112. So therefore A plus n minus 1 into D is the last term. The second last will be A plus n minus 2 into D. Similarly n minus 3 and n minus 4. This all equal to 112. Now from all this, this is A, 2A, 3A and 4A. And from here, here, here and here we can take D common. So we are left with n minus 1, n minus 2, n minus 3, n minus 4 multiplied by D. D we got is 2. So therefore 4 into A, that is 4 into 11 plus adding all this is 4n minus 10 multiplied by 2 is equal to 112. So we got this equation 8n plus 24 is equal to 112, and solving it we get 8n is equal to 88 or n is equal to 11. So therefore the number of terms in an AP is equal to 11. So the correct answer is B. Now the next question is if A1, A2, A3 and so on up to A to N are in AP, that is there are 2n terms in an AP, Then we want to find the value of a1 square minus a2 square plus a3 square minus a4 square plus so on up to a2n minus 1 square minus a2n square. Now we'll start with a1, a2, a3 and so on up to a2n in AP. Now the difference, since it's an AP, the difference of the two consecutive terms will be the same. That is a common difference. So a2 minus a1 will be equal to a3 minus a2 will be equal to a4 minus a3 and so on up to a2n minus a2n minus 1, which is equal to d. Now we want to find the value of a1 square minus a2 square plus a3 square minus a4 square and so on. So therefore a1 square minus a2 square plus a3 square minus a4 square plus so on. We can write it as, we'll combine these two together. A1 square minus a2 square, we can write it as a1 minus a2 multiplied with a1 plus a2. Similarly, a3 square minus a4 square is a3 minus a4 into a3 plus a4 and so on up to the last term. Now a1 minus a2 minus a1 is d, a3 minus a2 is d, so therefore a1 minus a2 will be equal to a2 minus a3 will be equal to minus d. So a1 minus a2 is minus d, a1 plus a2 plus minus d into a3 plus a4 and so on. Now we can take this minus d common, so minus d multiplied with a1 plus a2 plus a3 plus a4 so on up to a2n. Now this will be equal to minus d into 2n by 2 into a1 plus a2n. Now whenever we have arithmetic progression, then the sum of the arithmetic progressions is always equal to n by 2 multiplied with the first term and the last term. The first term is a1, the last term is a2n. So therefore we get the expression, because the total number of terms is 2n divided by 2 multiplied with a1 plus a2n. Now this minus will take out, and in place of d we can write a2n minus a1 divided by 2n minus 1. That is the last term minus first term divided by the total number of terms minus 1, and multiplied with, in place of minus, this minus, and in place of d this term, and then we have n and then a1 plus a2n, and this 2 and 2 get cancelled. Now this will be equal to this a2n minus a1, and here we have a1 plus a2n. This we can write it as a2n plus a1, and minus will take out, so minus will come out, so we'll get a2n minus a, this is a minus b, and this one will be a plus b form. So a plus b into a minus b will get a2n square minus a1 square divided by 2n minus 1, and from here we get n. So therefore we get the correct answer as A.